أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear student, Assalamu alaikum. Class 9, subject physics, chapter number 8, thermal properties of matter. And topic of today's lecture will be 8.2, where we left will be the continuation of the topic 8.2, and we will try to do 8.3 topic. The pages covered so far today 172, 173, so on 176. We will try to finish these pages. I repeat, class 9, subject physics, chapter number 8, and the name of the chapter is thermal properties of matter. Topic of today's lecture will be 8.2. The topic we left the numericals of 8.2 topic, and 8.3 topic we will try. 8.3 topic is specific heat capacity. We will try to cover these two topics today, and the pages are 172. Please open page 172. This is the chapter we are doing, unit number 8, thermal properties of matter. The name of the chapter is thermal properties of matter. So we finished till here. We in my last lecture we discussed about there are three scales: Fahrenheit scale, Celsius scale, and Kelvin scale, and I told you how they are divided. So Kelvin and Celsius scales are equally divided in 100 equal parts, while Fahrenheit scale is divided into 180 equal parts. So I told you in last lecture, but in today's lecture, we will discuss about conversion of the temperature from one scale into another temperature scale. I repeat, conversion of temperature from one scale into other temperature scale. For example, we are given temperature in Celsius, we can convert this into Kelvin. We can go to other scale. If we are given in Kelvin, so we can go into Celsius. So how can from here from today's chapter we will discuss about from Celsius to Kelvin scale, how we go from Celsius scale to Kelvin scale. If we are given the temperature in centigrade or Celsius, we can convert this into Kelvin scale by a simple formula. And the formula from going from Celsius to Kelvin is T of K, temperature in Kelvin, equals to 273 plus Celsius, temperature in Celsius. I repeat, temperature in Kelvin equals to 273 plus Celsius. This is the formula. 8.1 is the formula, which is on page number, please open page number 172. This whole thing, this conversion is on page number 172. Temperature in Kelvin is equal to 273 plus C. Okay. So I read the example 8.1. What will be the temperature on Kelvin scale of temperature when it is 20 degrees Celsius on Celsius scale? We need to find the temperature in Kelvin scale, while we are given 20 degree temperature in Celsius we are given. So Celsius temperature, so first of all I write the given data. Celsius temperature is 20 degrees Celsius, and we want to find out the temperature in Kelvin. I will use the formula, this formula, excuse me, which I explained you just now, and the equation 8.1. I will use this formula because I am given temperature in Celsius, and I want to find out in temperature in Kelvin. So I will just put in the values. Celsius value is 20 degrees Celsius. So I will put in Celsius temperature in this equation. So T of K equals to 273 plus 20. So my temperature in Kelvin will be 293 Kelvin. If I am given temperature in Celsius, I can go into Kelvin. So if temperature in Celsius is 20 degrees Celsius, then our temperature in Kelvin will be 293 Kelvin. So this is a formula in which we go from Celsius to Kelvin scale. Now I move from the same formula, but little bit change from Kelvin to Celsius scale. Here I am given a temperature in Kelvin. I want to find out the temperature in Celsius by using this formula. Same formula I use. this one formula I will use, but since I want to find out the temperature in Celsius, so I will move plus 273 on the other side of the equation. So my formula will become T of K minus 273 equals to temperature in Celsius. Same formula, but a little bit change. I'm moving this because I want to find out the temperature in Celsius. So that formula change T of K minus 273. So I'm given the temperature in Celsius 273. In example 8.2, change 300 Kelvin on Kelvin scale into Celsius scale. We are given the temperature in Kelvin and we want to find out the temperature in Celsius scale. Same formula, I will use this formula 8.2 to convert from going from Kelvin to Celsius. So temperature in Celsius is given to me 300 Kelvin and I'm just putting the values. Temperature in Kelvin is 300. So minus 273. So if you subtract this, you will find the temperature in Celsius. So students, this is very easy. Just you need to memorize this formula. Temperature in Kelvin is equal to 273 plus Kelvin plus centigrade. So you can either go from Celsius to Kelvin or from Kelvin to Celsius. So now this is another formula is coming in which I go from Celsius to Fahrenheit scale. I told you there are the three scales. One is Celsius scale, other one is Kelvin scale, and third one is Fahrenheit scale. But if I am given the temperature in Celsius, I can go to Fahrenheit as well. By using this formula, Fahrenheit is equal to 1.8 times C plus 32. 8.3 equation I will use if I am given the temperature in Celsius and I want to find out the temperature in Fahrenheit. Now, example 8.3, convert 50 degrees Celsius on Celsius scale into Fahrenheit temperature scale. So we are given the temperature in Celsius scale. So I need to find out the temperature in Fahrenheit. I will use this formula 8.3. Equation A height is equal to A 1.8 times C plus 32. You can use this formula to go from Celsius to Fahrenheit. So Fahrenheit is equals to 1.8 times C plus 32. Just plugging the value of C is 50 degrees Celsius. You know, it is given to me, I convert 50 degrees Celsius. So I just plug in centigrade 50 in this formula, I just plug in the values of Celsius, which is 50 degree given to me. So then multiply 1.8 times 50 plus 32, and then add them. So you will get the you will get the scale Fahrenheit value for temperature in Fahrenheit will be 122 degree Fahrenheit. I repeat, from here we have two forms. First of all, we discussed this formula. Now I'm discuss this formula for Fahrenheit is equal to 1.8 times C plus 32. If we are given the temperature in Celsius, we can go into Fahrenheit scale. So in this example, I am given 50 degrees Celsius temperature in Celsius is given to me, and I want to find out the temperature in Fahrenheit. I will use this formula. Fahrenheit is equal to 1.8 times C plus 32. Just plug in the values. C is 50 degrees. So 50 multiplied by 1.8 plus 32. If you multiply 1.8 with 50 and then add 32, you will get the temperature in Fahrenheit will be 122 degree Fahrenheit. So this formula is going from Celsius to Fahrenheit now. Similarly, I can go from Fahrenheit to Celsius scale. If I am given the temperature in Fahrenheit, I can convert this into Celsius as well. Convert example 8.4. If you look at the example 8.4, 8.4 example is on page number 174. Please open page number 174. I am given the temperature in Fahrenheit and I want to find out the temperature in Celsius. I will use the same formula which I discussed just now. This formula, Fahrenheit is equal to 1.8 times C plus 32. You a little bit change and then you can convert from Fahrenheit to Celsius. So you need to move one thing to other to in order to separate C. So Fahrenheit is given to mean 100 degree Fahrenheit. Temperature is given to mean Fahrenheit is 100 degree Fahrenheit. I want to find out the temperature on Celsius scale by using this formula. 1.8 times C equals to F minus 32. So C will be, it divide this one. So you separate out C, value putting the values. F is 100 degree Fahrenheit, 100 minus 32 divided by 1.8. So 100 minus 32 will be 68. When you 68 is C, because we want to find out the C, so here 1.8 is multiply. If it is go on the other side of the equation, it will be divided. So 68 divided by 1.8, you can get the temperature in Celsius will be 37.8 degrees Celsius. So student, if we are given the temperature in Fahrenheit, we can go into Celsius, or either if we are given the temperature in Celsius, we can go into the Fahrenheit by using these two formula. So there are actually the two formulas. One is this one, 8.1. So I discussed this with you, and the other one is Fahrenheit is equal to 1.8 C, 1.8 times C plus 32. This is the formula. These are the two formulas. With the help of these two formula, you can go from Fahrenheit to Celsius and Celsius to Fahrenheit. Similarly, from Kelvin to Celsius and Celsius to Kelvin as well. So you need to memorize these two formula. In 8.1, I told you about 8.1 and I told you about 8.3 equation. Fahrenheit is equal to 1.8 times C plus 32. Now I am moving towards 8.3 topic. My topic 8.3. The topic is specific heat capacity. The topic name is specific heat capacity, which is on page number 174. Please open page number 174 because I'm going to teach you 8.3 specific heat capacity. Topic is 8.3 specific heat capacity. So specific heat capacity, I just show you, explain you. So these are the specific heat capacities of the different substances. For example, specific table 6.8.1 specific heat capacity of some common substances. For example, specific heat capacity of alcohol is 2500 joule per kilogram per Kelvin. It is the unit of the specific heat capacity. Similarly, aluminium has a specific heat capacity is 903 joule per coulomb per Kelvin. And similarly, if you find out the specific heat capacity of water is 4200 joule per kilogram per Kelvin. And the dry ice soil specific heat capacity is 810 joule per kilogram per Kelvin. So I'm just making you familiarize with the what is specific heat capacity. I'll explain you what is actually the specific heat capacity. So this is the table of the different substances which has a specific heat capacity. So you need to memorize the specific heat of capacity of water is 4200 joule per kilogram per Kelvin, and that of dry soil is 810 joule per kilogram per Kelvin. And the unit of specific heat capacity is joule per kilogram per Kelvin. You need to memorize this. Okay. Generally, and now I'm going to explain you what is specific heat capacity. Generally, when a body is heated, its temperature increases. As you know, when we heat some substance or when we heat some body, its temperature goes on rising, goes on increase. Increasing the temperature of the body is found to be proportional to the amount of heat absorbed by it. So more the heat, more will be the temperature will be rise. So they are directly proportional to each other. More will be the heat, more will be the temperature of the body will rise. Generally, when we heat the body, its temperature rises. So if you have more heat, you have more rise of temperature. So delta Q is the change in heat when we provide the heat, and delta T is the change in temperature. If we have less heat, the less temperature will be rise of the body. If we have more heat, then the more temperature of the body will be rise. And it is also found that heat absorbed is directly proportional to the mass of the sub body. So greater the mass, greater will be the amount of heat. Lesser the mass, lesser will be the amount of heat. So these two are directly proportional to each other. What I'm saying, delta Q is the heat provided. So when we provide the heat to the body, its temperature rises. So the more the heat, more will be the temperature. Less the heat, less will be the temperature. Similarly, amount of heat absorbed is also directly proportional to mass of the body. So if we have a less mass of the body, so amount of heat will be less. If we have more mass of the body, the amount of heat will be absorbed will be more. So these two are directly proportional. So change in heat is directly proportional to the product of the mass and the change in temperature. If we remove the directly proportional sign over here, as you know, C is the constant of proportionality. When we remove the directly proportional sign, so with two things come equal sign and some constant of proportionality, where C is the constant of proportionality. It is called specific heat capacity, where C is the constant of proportionality and called the specific heat capacity of simple, or we simply say specific heat. Specific heat capacity's other name is specific heat. So C is the constant of proportionality and it is called specific heat. So how can I find C? So if M multiplied by delta T, if they are multiplying here, if it is go on the other side of the equation, so if I separate out C, so the C will be delta Q divided by M delta T. You can find out by yourself easily. You need to separate out C, where C is the constant of proportionality and it is called specific heat or specific heat capacity or simply specific heat. So if you want to find out the specific heat, so C can be separate out. So M delta T is multiplying with C. If it is go on the other side of the equation, they will be divided. So delta Q is M divided by M delta T. So C is specific heat. So SI unit of mass is measured in kilogram, and heat unit is joule, and temperature is measured in Kelvin. So our SI unit of specific heat capacity will be, I explain you. Mass is measured in kilogram. The SI unit of the mass is kilogram. Delta Q is the amount of heat absorbed. Its unit is joule. SI unit of the amount of heat is joule. And delta T temperature unit is Kelvin. Temperature is measured in Kelvin. So our specific heat capacity unit will be joule per kilogram per Kelvin. Joule per kilogram, as I told you, the specific heat capacity unit is joule per kilogram per Kelvin. How? Delta Q unit is joule and M unit is kilogram and delta T unit is Kelvin. So the unit of delta Q is joule and unit of mass is kilogram. SI unit of mass is kilogram. SI unit of the heat is joule and SI unit of the change in temperature is Kelvin. So our specific heat capacity is measured in unit of a specific heat capacity or simply specific heat is joule per kilogram per Kelvin. So I explain you what I explain you, delta Q is directly proportional to the mass and delta Q is directly proportional to the delta T. From this equation, when I remove the directly proportional sign, it will comes with equal sign and some constant of proportionality, where C is the constant of proportionality, which is called specific heat. Specific heat capacity or simply specific heat. The unit of specific heat capacity, I can separate out C, which is called a specific heat, because M delta T is multiplying with C. If it is go on the other side, it will be divided. So delta Q divided by M delta T. The unit of delta Q is joule. Unit of the heat is joule. Unit of mass is kilogram. SI unit of the mass is kilogram, and unit of temperature is the SI unit of the temperature is Kelvin. So specific heat capacity unit will be joule per kilogram per Kelvin. So this is the unit of specific heat capacity. So we study importance of large specific heat capacity of water. So that's why now I'm going to discuss some substance has large specific heat capacity of, for example, if you look at the table, you can find the specific heat of capacity of water is 4200. joule per kilogram, which is I think the more from in this table. So specific heat of water is 4200 joule per kilogram, and the specific heat of dry soil is 810. So and now I'm going to explain the specific heat capacity, the importance of specific heat capacity. So water has a specific heat capacity is 4200 joule per kilogram, as you know. You can see in the table 8.1 as I show you. As I showed you, the specific heat of water is 4200 joule, which is the highest one. Uh, which is the highest one. So specific heat capacity of water is 4200 joule per kilogram per Kelvin. So that's why, and the dry soil is about 810 joule per kilogram. As a result, the temperature of soil would increase 5 times more than the same mass of water. If we have a mass of same amount of water and same amount of soil, but in order because its specific heat capacity of the dry soil is very less, so it will take 5 times to reach the same amount of water. If we have 1 kilogram of water, since water has a large specific heat of capacity, which is 4200 joule per kilogram per Kelvin, that's why. But if we have same amount of soil, so 800 and its dry soil specific heat capacity is 810 joule per kilogram per Kelvin. So if we so that's why 810 is a very less quantity. So which is the specific capacity of the soil. So soil will take 5 times if we raise the temperature five times that of the temperature, same amount of that. So dry soil will be cold and hot at the same time quickly. As a result, the temperature of soil would increase 5 times more than the same mass of water by the same amount of heat. Thus, the temperature of land rises and falls more rapidly. This is because the dry soil has a specific heat capacity is less than water, so temperature of land rises and falls rapidly. So hence the temperature variation from summer to winter are much smaller at places near the sea than land far away from the sea. So the land which is near to the sea, because the specific heat capacity of the water is more, so there over there the temperature will rise more. Temperature will be more, and uh, the, the the areas which are away from the sea, their temperature is low because specific heat capacity of the water is more, uh, and than the specific heat capacity of the soil. So, since water has a large specific heat capacity, which is 4200 joule per kilogram per Kelvin, that's why we use water in the radiator of the car. Automobiles, some automobiles, but most of the automobiles use the water as a for the radiation because it has a large specific heat capacity. It is very useful in storing and carrying thermal energy due to the high specific heat capacity. Since water has a large specific heat capacity, that's why it has a capability to store and carrying thermal energy due to the high specific heat capacity. The cooling system of automobiles use water to carry away unwanted thermal energy. You might have seen in your cars, in the radiator, car's radiator, we use water as a radiator in the radiators, because why we use the water in the radiator, because the specific heat of water is very high, which is 4200 joule per kilogram per Kelvin. That's why water to carry away unwanted thermal energy. What is thermal energy? uh, Thermal energy is produced due to the car motion. If we move the car, so thermal energy will be used, and this thermal energy, uh, water water use this thermal energy to cool our cars, right? Because it has a large specific heat capacity. So, in an automobile, large amount of heat is produced by its engine, due to which its temperature goes on increasing. The engine would cease unless it is not cooled down. So, we use water in the radiator to cool down the engine. Water circulating around the engine, as shown in figure 8.6, maintain the temperature. Water absorbs unwanted thermal energy of the engine and dissipates heat through its radiator. So that's why we use water in the automobiles radiators to uh, to eliminate the unwanted energy, in unwanted heat energy produced by the engine. So water is used as a coolant in the radiator to dissipate the energy. So because the specific heat of water is 4200 joule per kilogram per Kelvin, which absorbs, which store or carry lot of thermal energy. So now I'm moving towards example 8.5. A container has 2.5 liter of water at 25 degrees Celsius. How much heat is required to boil the water? So first of all, I'm given data is mass is given to me 2.5. Volume of water is given to me 2.5 liter. You can see, and mass is also 2.5 kilogram. Because the density of water is 1000 kilogram per cubic meter. So similarly, 1 liter is equal to 1 kilogram per liter, and 2.5 will be 2.5 liter will be equal to 2.5 kilogram. So temperature is given to me 20 degrees. So specific heat of water is 4200 joule per kilogram per Kelvin, as I told you, and initial temperature is 20 degrees Celsius. It's given to me because we want to boil it. How much heat is required to boil the water? So the boiling point of water is 100 degrees Celsius. If we take the difference between these two, we will get the change in temperature, which is delta T. So T2 minus T1 equals to delta T, change in temperature. So 100, so T2 is 100 and T1 is 20 degrees Celsius. So our change in temperature will be 80 degrees Celsius. I will use the formula Q is equal to Cm delta T. So as I show you this formula, uh, the, he is not written this triangle sign in the formula, but the Q is equal to Cm delta T. I'm using this formula in this numerical. So Q is equal to Cm delta T, where is C the specific heat capacity of water. Specific heat capacity of water is 4200. M is found to be 2.5. I show you. M is 2.5 kilogram. I told you. And then delta T I just found is 80. 80 degrees. If you plug in the values over here, so if you multiply this 4200 multiplied by 2.5 with 80, you will get 840,000 joule. The unit of Q is heat is joule. The required amount of heat is 840,000 joule, or 840. If you write 30,000, so 840 kilojoule. So heat is required to be 840 kilojoule. I repeat, example 8.5. I use this formula, specific heat capacity Q is equal to Cm delta T. Just remove triangle sign in the formula. So you will find the formula Q is equal to Cm delta T, where C is a specific heat capacity, M is a mass, and T is the change in temperature. So I use this formula in this example 8.5. The container has 2.5 liter of water at 20 degrees Celsius. How much heat is required to boil the water? So since boiling of water, temperature of boiling water is 100 degrees Celsius, initial temperature is 20 degrees Celsius. So T1 will be 20 degrees Celsius, and T2 is the final temperature, which is boiling temperature of the boiled water, which is 100 degrees Celsius. So mass is given to me 2.5. So we can use this formula to find the change in temperature. Change in temperature can be found how? T2 minus T1. So T2 is 100 degree and T1 is 20 degree. So 100 minus 20 is 80 degree, 80 degrees Celsius, or equals to 80 Kelvin. I will use the formula Q is equal to Cm delta T, which is the formula of specific heat capacity. So specific heat capacity of the water is 4200. As you know, the specific heat capacity of the water is 4200 joule per kilogram per Kelvin. And M is 2.5 and delta T is just found is 80. So if you multiply this, you can find the amount of heat, which is 840 kilojoule. So this is the end of the today's lecture. In the next lecture, we will discuss about heat capacities and terms related to other terms related to heat capacity. So if you still have any questions in your mind, and if you did not understand any part of the today's topic, please let me know. I'm here to explain. Your homework is memorize the topic covered in today's lecture and write once on a rough registers. This is your homework for today's lecture. So if you still have any questions regarding today's lecture, please feel free to ask. Thank you. Ibrahim, Mehrunisa, Fatima, Aliza, do you have any questions? Please unmute your mic and ask.